Hey, shalom, shalom from your Dutch Uncle John, here to tell you what it is in God Math Part 5. Okay, we've talked about in other videos about how God has hidden pi and e, the natural logarithm, and the Pythagorean theorem, and so many things in his holy scriptures. Today we're going to talk about God's divine proportion. And before we start, I just want to remind you about, in Hebrew, each Hebrew letter has a gematria or geometry value, and here are the numbers. Then there are the final form numbers. There's 5 of those, and then it kind of circles around, and if you put Aleph with an apostrophe, or Bet with an apostrophe, Gimel with an apostrophe, that covers 1,000, 2,000, 3,000, and so on. In Greek, they also have values for their alphabet. It's called isopsephy, and here are the isopsephy number values. I'm not sure if we need them today, but just remind you of them. So let's go to Genesis 1:1. Bereshit bara Elohim et hashamayim va'et haaretz. In beginning created God the heavens and the earth. That second word is bara. We did a whole video on Bereshit. We've done countless hours on the first verse. But let's look at this second word, bara. Okay, it's a Bet, Resh, Aleph. It means to create. It means to fatten. We see this word show up in the Joseph story when Pharaoh has a dream and the skinny cows ate the fat cows. Okay, there's the bara in there for the fattened cows. So it's create, fatten, or fill. And another important term about bara in the terms of creating is it's ex nihilo, which is Latin for out of nothing. Okay, so you have nothing and poof, you've got something. And this word bara, it's only used by God, this verb. Okay, because only God can create poof out of nothing. Okay, so, and when we look at the first 3 words, Bereshit bara Elohim, let's just put them here in order, top to bottom. The first one, Bereshit, notice in the center of Bereshit you have an Aleph and a Shin, which is the word Aish in Hebrew, which is fire. So you have fire represented in the first word, and the letters around fire are Bet, Resh, Yod, Tav, which is Brit. So you have a fire and a covenant, which is a picture of the Abraham story. Whenever God puts him to sleep and blesses him, cuts the animals in half, you have a fire in the Brit, the covenant. And the fire shows up throughout the Old and New Testament, representing the Holy Spirit. We see God, the Holy Spirit, was showing up as a column of fire back in Exodus, whenever the Jews were crossing over the sea, and that pillar of fire protected the Jews from Pharaoh's forces, right? And in the New Testament, Acts chapter 2, the day of Pentecost, Peter preaches, and 3,000 were saved, and the Holy Spirit came down as tongues of fire. Okay, so throughout the Bible, Holy Spirit, fire are related. So in that word Bereshit, we do have a picture of God, the Holy Spirit, in there. In the second word, bara, well, bara is Bet, Resh, Aleph. Bet, Resh is bar, son. Aleph is God's letter. So bara kind of points to Yeshua, the Son. Bara, Son of God. And the third word, Elohim, Bereshit bara Elohim. Elohim is God, right? And Elohim, notice, ends in Yud Mem. Yud Mem is the plural ending, right? So we have Bereshit bara Elohim. It's kind of hinting at a spirit, a son, and a father. Very nice to work that in. And let me tell you a little bit about Hebrew verbs. Hebrew finite verbs have pronouns built into their formation. Okay, they call them pronomial suffixes. You know, they add different letters to the end of a verb to point out the pronoun. In English, we use separate pronouns: I, you, he, she, they, we, right? In Hebrew, it's built into the word. And if you look at bara, the way bara breaks down is he creates. It's singular masculine. So we have something called subject-verb agreement that you have to have, right? The subject and the verb have to agree. What is it? You don't say I is, right? You say I am. You got to put the right verb with the subject. Although, what was this, the story, the teachers having the kids write their pronoun sentences, and Tommy comes up and says, okay, it's I is, and the teacher interrupts and says, no, 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 Tommy, it's I am. So Tommy says, okay, I am the 9th letter of the alphabet. Okay, all right. So here you can't have bara is third person singular with a plural subject. And Elohim, which God is one, but he's a complex unity, a complex one. He is using third person singular verb with a plural subject. You know, that causes a red flag in my book, because they should match up. This would be like saying they, subject Elohim, plural, they creates. We don't say they creates, we say they create. But in Hebrew, in this verse, it's they creates. Only God can say this, because only God is a plural and a third person singular. Very nice. Okay? So let's go back and look at bara. Bara means to create something out of nothing, we said. Ex nihilo. So here's a picture of nothing. We'll let 0 represent nothing. Here's a picture of God. God is one. Aleph, one, the first, always. Okay? And it represents unity, it represents God. And if we take nothing and divide it by unity, we get the Greek letter phi. Now some people pronounce this in the world, they pronounce it phi. Okay, in the Western world it's pronounced phi. My friend Jack says pho where he comes from. Okay, so if we take nothing and we add God to nothing, we get something. Make sense? 0 plus 1 equals 1. This is the beginning of what's called the Fibonacci series. And how we get this series is we add the first two numbers, which was 0 and 1, and you get the third number. Okay, 0, 1 equals 1. If you want the series to continue, do it to the next two numbers. 1 and 1 add up to 2. And you can continue doing this. 1 and 2 is 3. 2 and 3 is 5. 3 and 5, 8. You see the series that's developing as we continue on doing this pattern. Okay? And each of these numbers is a Fibonacci number. Got it? Okay. Now, what's cool about this series of numbers, and you know there are other series of numbers, right? The even numbers, 2, 4, 6, 8, 10, or the odd numbers, or the prime numbers. This is a special series, Fibonacci series, where you obtain the next digit by adding the previous two. And this is a very cool series of numbers. It has lots of special things about it. Okay? One of which is if you square each number in a Fibonacci series, okay, notice that the first two add up to 1, which is in the original series. Add the next two. 1 and 1 is 2. It shows up in the original. 1 and 4 is 5. 5 is a Fibonacci number. 4 and 9 is 13, a Fibonacci number. And that continues on, you can see. Now that's very clever. Another cool thing is, if you add up, say, the first 3 Fibonacci numbers, we'll just exclude 0 for right now. We're going to add up the first 3 Fibonacci numbers squared. So 1 squared is 1, 1 squared is 1, 2 squared is 4. Add those up, you get 6. Add up the first 4, you get 15. The first 5 gives you 40. And the first 1, 2, 3, 4, 6 give you 104. Okay, so those new numbers that we just come up with, 6, 15, 40, 104, what's special about them? Because they are not Fibonacci numbers, but they are, each one is a product of Fibonacci numbers. 6 is 2 times 3. 15 is 3 times 5. 40, 5 times 8. 104 is 8 times 13. You see the cool pattern there. Okay? Oh, now another thing is, if you take the Fibonacci series and divide any number in the Fibonacci series by its predecessor. So we'll start here with 1 and 1. 1 divided by 1 is 1. We didn't start at the beginning because 1 divided by 0, that's undefined, right? It's mathematically impossible. Gives you infinity or gives you, we don't know what it does, but it ain't good math. If you take 1 divided by 1 is 1. Do 2 divided by 1 is 2. 3 divided by 2 is 1.5. 5 divided by 3, 1.6666. 8 divided by 5 is 1.6. I want you to start noticing a pattern of the quotients. 21 divided by 13, 1.61538. 34 divided by 21, 55 divided by 34. 89 divided by 55. You notice something? The 1s are all staying the same. Then all of a sudden the 6s stay the same. Okay, then we get a 1 that continues, an 8 that continues. I'm going to go bigger here and we'll just buzz through these quick. But notice the part that repeats in each one. 1.618, 1.6180, 1.61803. It keeps zeroing in. It goes a little bit higher, then a little bit lower, higher, lower, and it's zeroing in on some special number. And that number is phi, which we call the golden ratio. And it's one of these numbers like pi that it continues on and on and on. It never ends. It never repeats. There's no pattern to it. Okay? And it becomes an infinite number if you keep going far enough out to infinity. All right? So it's all zeroing down on this magic number. And let me jump ahead to some numbers way in the future in this Fibonacci series. Here's 196,418. The next one is 317,811. And if I divide 1 by the previous, it comes out to 1.61803398887. And notice that is that golden ratio out to how many places? 10 or 11? I don't know. Very nice. Okay? So what do we do with this golden ratio? And what does it represent? Well, let's start with a square. A square we know is 1 by 1. Okay? That's its proportions. If I cut it in half and add it to itself, I get a rectangle. Its proportion is 1 by 1.5. Right? Because we've added a half onto it. And if I add just a little bit more to the red side, so that now it is 1 is the height, and the width is 1.61803398887. It's phi, the golden ratio number. that rectangle has some really, really cool implications to it. Okay? Its dimensions are 1 by 5. Understand? All right. And you can represent this in a picture. The golden ratio is, if you take A plus B and divide it by A, so you're taking the length divided by the width, it's going to be the same as if you take the sections of the length. A divided by B will give you phi. A plus B divided by A will give you phi. It's the ratio of the longer side to the shorter side. Okay? And it'll come out to be this magic number, this divine proportion. Okay? And other cool things about it, if you take the number phi and square it, so you're multiplying it times itself, you get 2.6180339887, on and on and on. And it mirrors the original phi, it's just one higher, right? Phi was 1.618, on and on and on. Phi squared is 2.6180, on and on and on. And they all match up. Well, that's kind of clever, that its square is one more than itself. And if you divide 1 divided by phi, so that's 1 over 1.6180, on and on and on, its result turns out to be 0.61803398, on and on and on. Wow, now that's a pretty magic number, right? If you square it, you get one more than its original, and if you divide 1 over phi, you get one less than the original. Wow, that's pretty cool. Okay, so what do we do with that? And by the way, that is called the golden ratio, or divine proportion. Okay, mathematically, here's the official formula for mathematicians who want to know what we're doing here. That's how you generate this magic number. Okay, there are other ways to generate this magic number. One of them is putting this formula, the square root of 1 plus square root of 1 plus square root of 1 plus square root of 1, and you're just doing the square roots to infinity. Okay? Or you can obtain this number by doing 1 plus 1 over 1 plus 1 over 1 plus 1 over 1 plus 1, and on to infinity. How you would begin to solve that, I don't know. I was a math major, I don't remember. But anyway, there it is. That will give you the Fibonacci series. Okay? Or this Fibonacci series, it will give you phi, right? The golden ratio. You can also obtain it by this little formula, 1 plus the square root of 5 divided by 2, which would be 1 plus 2.236067977 divided by 2, which is phi, the golden ratio. You can also take the sine of an angle, 666. That gives you negative 0.80901699437, which, if you multiply it times negative 2, it comes out to phi. You can also take the cosine of 216 degrees. 216 is 6 times 6 times 6. And that will also give you negative 0.80901, on and on and on, which you can multiply times negative 2 and get phi. So there are many different ways to obtain phi, this magic number. Maybe the simplest is, at the beginning anyway, is just to add the last two numbers, and it'll give you the next one, and then you divide the final two. That works up to a point. I mean, it goes on for infinity, right? So you can't just do that manually for infinity. So that's why some of these other formulas will generate this number much quicker. Okay, so let's look at some applications of the Fibonacci series and what we can do with it. The first one we said was 1011, And if we start with just a square here, it's 1 by 1. If we do the next Fibonacci number, it's 1 and 2, okay, and so 2 divided by 1 gives you a rectangle. It's 2 by 1, its dimensions. The next one, you have 2 and 3 are the Fibonacci series numbers. 3 divided by 2 gives you 1.5, and you've created a rectangle that's dimensions are 3 by 2. Next one, 3 by 5 gives you a rectangle. And remember, we showed you the rectangle. Remember, a plus b over a equals a over b equals phi. These rectangles are getting tighter and tighter and tighter to the exact number of phi. We can do the next one, 5 by 8. Okay, gives you a rectangle of those proportions, 1 to 1.6. Next one, an 8 by 13. Continuing on, 13 by 21. Next one, 21 by 34. If you divide those, you get 1.619047, which is getting very close to phi. All right? And I've just continued on here with a list of them. You can see how the numbers get closer and closer to phi. Here, way in the future, we have 6,765 divided by 4,181 gives you 1.6180339, on and on. But you can see how it is zeroing into the golden ratio number. Okay. Another cool thing about this is it doesn't matter what two numbers you start with, it's going to zero in on phi. Let's just, for example, we'll let the first number be 10.
Bingo!
We got a winner. And the second number will be 41. And if you add these together, 10 and 41 is 51, and then 41 and 51 is 92. I'm doing the same thing that I did on the Fibonacci series. You notice you take the last two and add them together to get the next number. And notice that it's zeroing in on 1.62, 1.61, 1.618, and you can continue on. It doesn't matter what two numbers you start with. If you follow this pattern, it will generate the golden ratio. Very nice. We just happen to start with 0 and 1. Okay? So now we take this rectangle that we formed by adding squares, right, to our Fibonacci series. And if you notice, you can start connecting these and it forms a spiral. Very nice. This is called the growth spiral. Okay? You can see things in life that follow this growth spiral. I'll tell you what, let's take a little road trip to my wonder room and I'll show you a few examples. Come on. Welcome to Dutch Uncle's Wonder Room. We're going to show you some really cool examples of the growth spiral, starting with a pine cone. Let's zoom in and get a closer look. You can see on the pine cone there is a growth spiral that comes out from it. And you can count the number of these little things, whatever they are. 1, 2, 3, where do we start here? 1, 2, 3, 4, 5, 6, 7, 8. There's 8 that go out and around, which 8 is one of the Fibonacci numbers. Clever, clever. Another place where we see the Fibonacci is in sunflowers. In fact, I've been told that there are 34 spirals that come out of the center, 34 being a Fibonacci number. So let's do a close-up. But you'll notice the spirals go two different ways. What else? Here we have This is one of the famous things, a nautilus shell. And if you slice this open, it's got all these chambers, but it's also has this growth spiral. You can see it that comes out and around. Very nice. And just for entertainment's sake, I have a rather extensive seashell collection, which I keep scattered on the beaches around the world. But some of the more unique shells I have here, you've heard of the nautilus. But what about the paper nautilus? I don't know how good this is showing up, but this is like just wafer thin versus this is a hard shell. This you could crush easily. Very nice. And so many shells have this spiral to them. Here's just a rather common shell, but it has the spiral. Here's a very unique one. Notice the spiral in the back first of all. Okay, it is spiraling around, but look at the top of this. It has all these spikes that come out. Is that just too cool? This one. Here we have the growth spiral inside here. But on the outside, whatever lives up inside here, he goes around and picks up other shells and glues them to himself. It's called a carrier shell. How clever is our God? In the animal kingdom, we have an example of a growth spiral. Ram's horns. Grow in the growth spiral. Hello. Okay. That's it for Dutch Uncle's Wonder Room. Back to the studio. Okay. Now, a few of those, there's some extra ones that we didn't show you in the Wonder Room. I'll show you now. We have, a pineapple. If you notice, a pineapple has that spiral pattern to it. Okay? So pineapples grow in that shape. Trees, since we're talking about plants, trees branch. Most trees branch in Fibonacci numbers. You have the original trunk, and then another branch comes out. So now you have two. And the next season you've got another couple branches. So you have 3 different branches coming out. And then in the next season you have 1, 2, 3, 4, 5 branches, then 8 branches, then 13 branches, all Fibonacci numbers. Wow, isn't that amazing that this mathematical sequence, which is just math, which is just numbers, but somehow crosses over into life, and things are being shaped and formed based on this series of numbers. How does math numbers get connected to actual life things, right? I contend that there is a creator who has connected these two together. Okay? It's not just happenstance. Okay, so we've shown you examples of seashells, flowers, pine cones, seahorses, ram's horns. When I was in South Africa, we saw the greater kudu. Its horns have that growth spiral to it. Here's another cool application. Look here, we have an M and an F. That's a male bunny and a female bunny. So we actually have one pair of bunnies. Okay? and they're just born, so they're babies. Okay, and in the next month, the second month, the first month they're born, the second month they're growing, all right? And it's not until the third month that they become old enough to reproduce. And when they reproduce, they create another set of babies, male and female. So originally we had one pair. By the third month we have two pair, and 2 is a Fibonacci number. In the next month, the original pair has another pair, and the first offspring is now in its growing month. So, but we have 3 pair. If you go to the next month, the original pair has a new pair. Its pair from last month is growing, and its first offspring is now adults, and they produce offspring. So you have 5 pair of bunnies. In the next month, we'll follow that same logic. Some of the groups were already adults, they're having another pair. Some of the groups that were just born the previous month are in their growing month. And some of the earlier offspring are now old enough to have offspring of their own, and you end up with 8. And then the next month you have 13. But they're reproducing pairs in a series of Fibonacci numbers. Okay? So again, it's math and science, or math and biology, are intersecting somehow. Very nice. Notice the human fetus is, this is a human fetus of 3 months old, but there is a growth spiralness to it. Our DNA, here's a DNA strand. If you measure the width of a DNA strand, it's 21 angstroms. We're talking very small measurements here. And the length of one series from one point to the matching point on the DNA strand is 34 angstroms. Notice 34 and 21 are both Fibonacci numbers, and out comes 1.619, which is the golden ratio, divine proportion. All right? In your ear, you have the cochlea, which helps with hearing, right? But notice it follows the growth spiral. Here's a human being. And I would think the middle, what we consider like maybe the middle and most important, is your navel, right? If you go from the bottom of your feet up to your navel, and then from your navel up to the top of your head, that becomes a 1 to 1.618 proportion. So we humans are even built in this pattern. Okay, you've seen Michelangelo's Sistine Chapel. I just need a picture of a man. So we'll use the one that he painted there on the chapel ceiling. Here's God creating Adam. Notice Adam's arm. From his shoulder to his elbow is 1. From his elbow to the tip of his finger, 1.618. Same applies with God's arm reaching down. Notice that God's arm, when he's reaching, his finger is extended, reaching out as far as he can to Adam. Adam's hand is kind of bent. And isn't that the way it is? God is reaching for us, and we are reluctant to reach out to God. I like that Michelangelo implied that in his picture. Very clever. You can also see it in from your wrist to your finger is 1, from your wrist to your elbow 1.618. Same with God's arm. Look at the actual finger. Your finger has 2 joints and 3 phalanges, I guess. You can see this first piece here is 1, and then from your first knuckle to the tip of your finger, 1.618. You can also see it on the tip of your finger is 1, and from the tip of your finger to the second knuckle there is 1.618. Throughout our body, this proportion goes over and over and over, okay? In fact, his entire picture up there follows that golden ratio spiral, the growth spiral. Very nice. The human face has lots of these proportions. What is it? From the tip of your nose to your eye is 1. From the nose to the chin is 1.618. There are just the shape of the head, the length and the width. And you can look it up online. There's many examples of the golden ratio that shows up in a human face. Okay? Leonardo da Vinci, when he painted the Mona Lisa, notice you can see the growth spiral that he used. You know, this growth spiral, it happens so much, and it's so in our lives, in every aspect of our lives, that it becomes familiar. And when we see things that grow or see things that are formed in this spiral, it is pleasing to us because it's familiar to us. Understand? So if something, you look at a painting and go, ooh, that's odd. It's because it's not in the right proportions for what is programmed into us. Leonardo also, remember he did this, the Vitruvian Man drawing. And this isn't exactly 1.618, it's like 1.64. He was a little bit off, but remember, this is 500, 600, 700 years ago. He's working on it, okay? Leonardo da Vinci got it close. Michelangelo got it closer. Fibonacci was before all of them. Fibonacci was around 1170 to 1240. That's where he came up with his numbers. A couple hundred years later, Leonardo da Vinci is fine-tuning it, and then 100 years after that, or not even that, Michelangelo is perfecting it even further. Okay? Let's look at music in the Fibonacci series. We have an octave. An octave consists of 13 notes. Notice 13 is a Fibonacci number. And of those 13 notes, 8 of the keys are white. 8 is a Fibonacci number. 13 over 8 gives you 1.625, gets you very close to 5. Total number of white keys, 8. And in that octave, same octave, you have 5 black keys. 8 over 5, 1.6. So music follows this Fibonacci series number. A scale is composed of 8 notes. If you want to make a chord, you use the first, third, and fifth note. It's a basic chord. First 1, 3, and 5 are Fibonacci numbers. And the full chord, you can go all the way up to the 8th note, which is also a Fibonacci number. In the bass clef, you have the treble on the top and the bass on the bottom. Notice the bass clef looks like a growth spiral. So music has lots of tie-ins with this Fibonacci series. If you want to go even bigger, hurricanes grow and are formed in the growth spiral. This one, look at this. This is, we call it the pentagram of Venus. Notice you are there in the center on the earth. And if you look up into the night sky, or early morning sky, I think Venus is the early morning star. And if every morning you get up and you mark on a piece of paper, the paper represents the sky, where is Venus? And you keep tracking that every morning, this is the pattern that will emerge. Beautiful. There is some beautiful logic and thought that went into these the elliptical orbits of the different planets. And then they end up forming these beautiful geometric shapes. Okay? And with Venus, the successive inferior conjunctions of Venus repeat very near a 13/8 ratio. 13 and 8 are both Fibonacci numbers, right? In other words, the Earth orbits the Sun 8 times for every 13 orbits of Venus. Understand? We go around the Sun 8 times, and in that same period, Venus goes around the Sun 13 times. Oh, and by the way, inferior conjunction, conjunction, junction, what's your function, right? It's lining up planets in line with the Sun. Notice here, you have the Sun, Venus, and Earth. We're all in line. That's an inferior conjunction. A superior conjunction is when we're aligned, but the planet is on the other side of the Sun. Okay? And it's very cool how it comes into the center and kind of swirls back. There is a, what do they call it, retrograde motion. Sometimes when you're watching the sky for Venus, Venus is moving ahead, moving ahead, moving ahead, and then all of a sudden it starts moving back. And that's that little twirl in the center there by the Earth. It looks like it's moving backwards. It's not. It's just not moving forward as fast as we are. Okay? But very nice how this Fibonacci series even deals with the planets in their orbits. Okay? So Venus orbits the Sun 1.62551 times in one Earth year, is the bottom line there. Okay? Look at galaxies. Galaxies have that growth spiral, which we obtained from the Fibonacci series. Here's the Whirlpool galaxy, spiral. The spiral galaxy, spiral. Very nice. So we've seen examples of small, medium, and large things that follow the growth spiral, right? DNA, pine cones, small, hurricanes, medium, galaxies and planetary orbits, large. So the growth spiral comes in all shapes and sizes. Well, I guess it only comes in one shape, spiral. Okay. Oh, by the way, the small, medium, and large here, that reminds me, I don't know if you saw, well, you don't know when, I don't know when you're watching this, but in this morning's paper, the big story was that the circus is in town. And there was some incident last night between a clown, got into an argument or a fight with a midget fortune teller. And they got into this big fight, and ended up the midget fortune teller killed the clown and then took off. And there's a bolo, be on the lookout, or all points bulletin for this midget fortune teller who's on the lam. But it was on the front page of the paper. The headline read, small, medium, at large. Okay, let's take this growth spiral and let's see if it has any applications in the Bible. Because there's definitely a connection between the growth spiral and the Fibonacci math, right? They connect. Does God use any examples in the Bible? Well, look at Genesis 6:14. God's telling Noah, make for yourself an ark of gopher wood. You shall make the ark with rooms and shall cover it inside and out with pitch. That word for ark is tabah. And this is how you are to build it. The ark is to be 300 cubits long, 50 cubits wide, and 30 cubits high. All right? If we take the width of the ark divided by the height of the ark, that's 50 over 30, which reduces to 5 over 3, both Fibonacci numbers, 1.666. If we take the width of the ark divided by the length of the ark, that's 5 over 30, which is 0.1666, which would be 1 over phi. Look at Exodus 25, 10 and 11. This is the Ark of the Covenant. They shall construct an ark of acacia wood, 2.5 cubits long, and 1.5 cubits wide, and 1.5 cubits high. You shall overlay it with pure gold. Inside and out you shall overlay it. You shall make a gold molding around it. This word, by the way, for ark is not the same as Noah's ark. Noah, his ark was a tabah. This is aron. Aron is an ark or a chest. It's not the same. In English, ark, the same. No, not in Hebrew. But the dimensions he's giving here are 1.5 by 2.5 by 1.5, okay, which, if you multiply each one by 2, its dimensions are 3 by 5, you see. And there you can see that the ark and chest are different. But its dimensions here are 3 by 5. Both are Fibonacci numbers. Very nice, okay. Let's take Jesus Christ's name, Iousus Christos. Iousus in Greek adds up to 888. Christos is 1480. Okay, which, by the way, if you take the digits of those numbers, 888, 1480, and add them together, you get 37, which, there's our 37s again, right? 3 and 7. God's complex unity and God's perfection, his 7. Very nice. 888 is 3 times 296. And 1480 is 5 times 296. And there we have a 3 by 5 hidden in Iousus Christos, in Jesus Christ's name. Very clever. Okay. Look at Yahweh's name, Yud, He, Vav, He. There are the gematria values. Yud divided by Vav is 10 over 6, which is 5 over 3. Gematria, and those are Fibonacci numbers, 1.666. Yod plus Vav divided by He plus He. 10 and 6 is 16 over 10, which reduces to 8 over 5. 8 over 5, both Fibonacci numbers, comes out to 1.6. You can do the reciprocals. Vav over Yod is 6 over 10, which is 3 over 5.6. That's 1 over 5. He and He over Yod and Vav is 10 over 16, 5 over 8. It's 1 over 5. So God even has this divine proportion hidden in his own name. Beautiful. The Bible contains 39 books in the Old Testament, 27 books in the New Testament, a total of 66 books. If I divide 66 by the golden ratio, I get 40.79. The 40th book of the Bible is Matthew. Matthew is the kind of the navel of the Bible. This is where it gives the genealogy of the Messiah, right? And remember, the navel on a human being is the kind of the point where it's 1 to 1.618. Okay? So it even shows up biblically in the books of the Bible. Let's again take Jesus Christ, his name, Iousus Christos. Put in the isopsephy values. We said we're 888 and 1480. Christos divided by Iousus is 1480 divided by 888, 1.66666. Very close to phi. Iousus Christos divided by Christos is 2368 divided by 1480, 1.6. If we put it into our rectangle picture, it would kind of represent like this. Iousus Christos divided by Christos. Very beautiful. Just brilliant. Okay, now let's take that Fibonacci number, okay, the Fibonacci series, and we're going to play a little game here. If the number in the Fibonacci series is odd, we will turn left and go 1 unit. If the number is 0, we won't do anything. And if the number is an even number, we will turn to the right and go 1 unit. Got it? All right. We will start at this point and we're heading to the right. The first number is 0, so we do nothing. The next number is 1, which is odd, so we turn to the left and go 1 unit. So we're going up. The next number is 1. We turn to the left and go 1 unit. The next number is 2. 2 is even, so we turn to the right and go 1 unit. Next unit number is 3, is odd, to the left, 1 unit. 5, left, 1 unit. 8 is even, to the right. 13 is odd. 21 is odd. 34 is even, so we turn right. 55 odd. 89 odd. 144 is even. We turn right, 1 unit. We form a cross. Beautiful picture. All right, my friends. I'm sure you can find heaps more on the internet about this subject. I hope this at least whet your appetite. To God be the honor, to God be the glory, to God be the praise. And we will see you soon. Bye-bye. Wait! We have a bonus. We showed you how that Fibonacci series will create this rectangle. The rectangle will then generate a growth spiral, right? In this rectangle, let's put 37 in each box. So we start with the first one, which is a 1 by 1, a purple one there. We'll put a white 37 in there. And then we put a 37 in the next one. There's a 2 by 1. Then it was a 3 by 2. Then a 5 by 3. Notice I'm putting 37s in each box. Okay? In the 5 by 8, 5 by 8, by the way, is 40, right? And 40 times 37, because we're putting 37 in each box, that comes out to 1,480. Okay? And if you remember, 1480, that's the isopsephy value of Christos. Very nice. Continue on to an 8 by 13 and put 37 in every box. We've added a square here, right? The red is an 8 by 8, which is 64 little 37s, and that adds up to 2,368. 2368. Remember what that is? That is Yeshua 888 plus Christos 1480. Gives you 2368. Very nice. So in that rectangle, that golden ratio, divine proportion rectangle, you have Yeshua HaMashiach, Jesus Christos, hidden numerically in this. And the 37s weave in as well. Very beautiful. Beautiful, brilliant. All right, my friends. God bless. There's your bonus. Thanks for watching. Bye. Bye.